Good evening, dear student. Now, in this video, I am going to discuss about the electric flux. Dear student, electric flux is very important topic and Gauss theorem is based on this electric flux here. So first, what is electric flux? For this purpose, I want to tell you, first thing, in electric field, a large number of electric line of forces exist. Suppose in whole this whiteboard electric field exists, then you can say there is a large number of electric line of forces is exist in this board here or in the plane of this board. So only one thing you remember, electric line of forces exist in electric field, like magnetic line of forces exist in magnetic field. So here, what is the electric flux? Electric flux is the measure of electric line of forces when a surface or passes through a surface held in electric field. Suppose this one is the electric field, this one is electric field, and this one is electric line of forces which lies in any electric field, and a surface is held in it, any surface which is held in it here. So the electric line of forces which passes through this surface is called electric flux linked through this surface here. And suppose this one is electric field and this one is a surface which held in this electric field, and then electric line of forces which passes through this surface which held in this electric field is called the electric flux. Actually, electric flux is denoted by phi E. So phi is used for flux. If E is here, then this one is electric flux. And if you will consider a small area on this surface, suppose this small area is dA, small area dA, and axis of this area vector for this small area, its area vector is suppose along this one, which is always perpendicular to this small area element. And suppose this one is electric field E, then electric flux passes through this small area element dA is denoted by d phi E. d phi E means a small electric flux passes through this small area element, and that area element is taken on that surface which is held in this electric field, and that small electric field d phi E is equal to vector E dot vector dA. So electric flux, this d phi is what here, electric flux passes through this small area element. So the electric flux d phi E is the dot product of vector E and dot dA. So electric flux passes through whole area. How can we find? By integrating this one. So when you will integrate it, you will write d phi E is equal to vector E dot vector dA. And when you will consider this whole area, so this one is called surface integral. Here you will write here A. This A means this one is called for whole area, or this one is called surface integral. Surface integral. So d phi is a small electric flux passes through the small area, and for finding the electric flux passes through the whole surface, what you will do? You will integrate this one here. So integration of d phi E is equal to whole integration vector E dot dA. Here A means for entire area, or this one is called surface integral. And integration of d phi E is what here? Phi E is equal to whole surface integral E dot dA. Dear student, all of you know the dot product of two vector, suppose A and B are two vector, then their dot product is given by A dot B is equal to AB cos theta, which already you have studied in the class 11th. So at place of E dot dA, you can write E dA cos theta. And finally, you will take E cos theta outside, E cos theta outside, and here you will get dA for this area element. And electric flux phi E is equal to E cos theta, and integration of dA means dA is the small area element taken from this surface, and whole integration of dA means total area of this surface, which is A. And finally you can say this is equal to EA cos theta. So dear student, remember this, electric flux passes through a surface is given by phi is equal to EA cos theta. Now E is electric field, A is area of that surface which is held in the electric field, and dear student, theta, be careful about this theta. Theta is the angle between electric field and axis of this area or area vector. Area vector means that line which is perpendicular or normal to that surface and directed outward, means angle between electric field and area vector. This one is a area vector and this one is a electric field. So theta is the angle between electric field and axis of this area vector. Suppose you can also take the example of umbrella. If you will take one umbrella, dear student, you can also understand the electric flux with the help of this easy example. And in this example, suppose in rainy season, during the rain, when an umbrella is held in this rain, then some raindrop will be fall on this surface of this one and some will be goes out. Suppose this one is what here, raindrop. So this one is, suppose your raindrop will be act as a electric field. This one is a surface which held in this electric field, and now the handle of this or this stick or this handle of this umbrella is act as the area vector or direction of this area vector. This one is direction of this area vector, this one, and always this will be normal to this surface and directed outward. And always we consider in this phi is equal to EA cos theta. Theta is the angle between electric field and area vector. Area vector means the normal on that surface which held in that electric field. So here normal of this surface is act as this handle. So theta is the angle between electric field like this rain and its handle, and you see here both are parallel. It means here theta is equal to 0 degree. So angle between electric field means like this raindrop, and the handle of this umbrella be act as a axis of this area vector, and then both are parallel, then you can say theta is equal to 0 degree. But so dear student, you see here in this case, when this umbrella will held in this rain, then raindrop will be act as a electric field or electric line of forces, and this one is a surface of the umbrella and this one is a stick. This stick is normal to this surface and act as the axis or area vector of this surface. And in this case, phi is equal to EA cos theta. So here theta is what? Angle between this electric line of forces means electric field, and this one is what here? handle are axis of this area vector. So this electric field and this area vector both are parallel. It means theta is equal to 0 degree. And in this case theta is equal to 0, then electric flux passes through this surface is phi is equal to EA cos 0. And dear student, you know cos 0 is equal to 1. So phi is equal to EA. Phi is equal to EA means in this case this electric flux becomes maximum. It means when electric field and this area vector both are parallel, then in this case maximum electric flux is passes through this surface. Second case here, if suppose this umbrella is little tilt like this one here, so in this case now its axis of this area vector will comes like this. Raindrop which is act as an electric field remains same, and now suppose the angle between this electric field and axis of this area vector is theta, and now in this case you can say here phi E is equal to EA. Suppose I am taking this theta is equal to suppose 30 degree. So you can take here EA cos 30, and now you will put the value of cos 30 and you can find out the electric flux passes through this surface. Again, when it rotate and suppose the umbrella will becomes like this one, in this case its handle comes like this and electric field is downward. And now what is the angle between this electric field and this one? This angle is 90 degree. So in this case theta is equal to 90 degree and electric flux phi E is equal to EA cos 90, and cos 90 0 means electric flux is 0. It means in this case no any electric line of forces passes through this surface, or in this case no any raindrop is passes through the surface of the umbrella. So dear student, in this video I want to tell you only about how can we calculate the electric flux passes through a surface when the surface is rotated in the electric field. So please once you also take the help of your book and go through this topic, and tomorrow again I will tell you some more points regarding this electric flux. Thank you.